So I guess for the next section, we're going to convert this into Lightning, into PyTorch Lightning, right? Mm-hmm. So basically, at a high level, PyTorch Lightning is not going to really abstract anything. It's just going to organize the code, and then it's going to allow you to remove a lot of the boilerplate.
Can't wait to see how you can improve this stuff.
Yeah, of course. Okay, so now we're going to convert this to PyTorch Lightning, and it's going to be literally most of the same code. In fact, we're just going to lose code for the most part. So first, I need to install Lightning, right? So this is just pip install. Cool. So that will actually install Lightning.
Okay.
And so it's installed. And then I'm going to import all of the standard stuff you did from the last video as well. We need 5 ingredients, right? So the first is you need your model. You need to figure out what that is. Then you need your optimizer, right? What are we using to optimize? Then you need your data. Then you need your training loop, right? So this is like the magic, right? It's where you spend 90% of your time, at least in Lightning. Otherwise, it's not in Lightning. You spend 90% of the time debugging all the other things. And then you have your validation loop, model, optimizer, data. I believe that's it. Yeah. And then, if you do have a validation loop, the validation magic, right? Cool. So you need to find these elements in the system.
Okay.
To start, you start with this class. It's called the Lightning module, right? So let's call this image classifier, because we can make it general beyond MS classifier. And so in Torch you had nn.module, right? And you in fact already have a RESTnet here, right?
Yep.
So you have this guy here. So let's go ahead and just copy all that stuff. And my Vim is stuck. Okay, great. So I'm just going to call this stuff. So let's call this, let's just drop it all in here. So we can do it 2 ways, right? So I can literally copy this code in here. Mm-hmm. And then in this case, this is just a RESTnet, right? So that's one way to do it. And then the second way is to just make this into an image classifier, right? Classifier that itself takes a RESTnet, right? Mm-hmm. So here it would be like def. Here we just call it like self.RESTnet, and then we'll use this RESTnet from up here, right? Yes. So we can do it this way. So in Lightning, it's just the PyTorch Lightning module. It's the same thing though. You can use it exactly the same as an nn module. So all you have to do is change this now.
Oh, we have already imported that. What is PL?
Oh, good point. Yeah. So PL is PyTorch Lightning.
Okay.
So import PyTorch Lightning as PL, right? So PyTorch Lightning. So now here's our Lightning module, right? And now you'll notice if you try to this is fine. It's just a model. Nothing's going to happen. If you try to init this, for the most part, right, you'll see this here. Let's see. So here you can use this as a model, right? This is exactly like nothing happened. This is literally the same as an nn module. So again, I can just change this just to illustrate the point that this is exactly the same thing, mm-hmm. right? So you get this, and it's the same functionality. The difference is in Lightning, though, that there are added methods that you can implement, right? So we talked about these ingredients, the model, the optimizer, the data, and so on. So let's first figure out what the optimizer is, right? So you had an optimizer down here somewhere. Where is that guy? Here, this thing, right? So, and you had this parameters thing. So let's bring both of those in. So Lightning has a function in the Lightning module called configure optimizers, right? So def configure optimizers. And you're just going to tell it what optimizer you want to use, right? So in this case, we want to use this. So you'll notice something. The model, it's weird because you're defining this within the model, right? So the parameters are not really there. So now you're just going to get the parameters from self because you're in that model, right? And so you need to just delete that and then you're done. So it's the same thing, but you're within the module. So optimizer. In this case, we're only using one optimizer, but if you were like making a GAN or something, you would have multiple, and you could have many of these, right?
Show that next time, right?
Yeah, exactly. And so each one of these will give you an actual training loop itself.
Also,
but right now we're just...
Pay attention, I spell things with an S.
Oh, sure. Yeah, no worries. Okay. So we're good. So now we have this optimizer model. You have your optimizer. We're going to leave the data last. Let's just implement the training loop first, right? Okay. So here, it's just called training step, right? So self batch, you get the batch and then you get the batch index.
Is it a reserved method, this one?
Yeah, it is. So this is something that this is part of the Lightning module, right? So Lightning module, again, it's just the NN module, but we add methods to it. So this is an added method. This is an added method.
I see. Okay.
So the training step is like the magic. This is like where 99% of the research happens, right? And in this mess of like training loop stuff, it's really like you only care literally about these 5 lines here, right? This is it. Like if you were to take your project and try to start a new project from it, like you would pretty much have to do all of this again, right? And the only thing that would really change is this guy here. So that's your training step. So in that instance, we're just going to literally copy paste that on here.
Okay.
Cool. So it's the same thing, right? Cool. So we don't really have to change anything. It's all basically the same, except the model is you're in self now. So we're just going to do self, right? Okay. And then your loss, you have to define your loss. So in our case, the loss was this cross entropy, right?
Yep.
So, you can do it 2 ways. I mean, you can do it the same way that you did it, where we had where are we? Here. So this loss, we want to attach it to this module. So, right. So we can do something like loss equals this, same thing. And then, and now we can do this self.loss and we're good. So the other difference is in Lightning, you don't need to do any of this CUDA stuff. So you can get rid of all of this.
Even if you want to run on CUDA?
Yeah, exactly. So Lightning will just put it on the correct devices for you. So you never have to worry about this stuff.
Okay.
I'm going to solve our logits problem by just calling it logits.
Okay.
Cool. Okay. So again, this is literally the same code you had. You still need data, right? So Lightning has multiple ways of doing this. Depends on your use case mostly. If you just want to kind of not mess, like if you want to make this model, so here, this is a RESTnet, right? So it's kind of, if you want to couple it with the data for whatever reason, you can do something like def training, I think it's train data loader. Okay. So if you want to do that way, then you're going to end up kind of coupling this thing with your data, right? So it really depends what your particular use case is. So in a lot of cases, why you would want to do this is because sometimes, for example, if we're not doing MNIST and we're doing ImageNet or some other thing, you need to know what the number of classes is, right? And that's going to come from your data. So a lot of times it's useful to know what that is. And so sometimes you just want to define that on here.
Yes, I see.
Yeah. Okay. So it's the same thing that you had. I just pasted it. And then we have these kind of splits, right? So I'm going to leave this as this right now, and I'm going to just return the train loader because we're not actually going to use
a parenthesis. Appeared. Batch side
here. Yeah, great. So we're not actually using this val data loader, so I'm going to block this out for now, right? So we don't actually need this. So we'll just keep this stuff here.
Train data though.
Yeah. Cool. Okay. So we're not actually going to use a validation set at the moment. So we're just going to use this train.
Okay.
And that should be it. We need to return this loss. So what you're thinking about it is, it's like this little block here is what's going on inside that training loop, right? So all of this stuff, we copy pasted from here, right? It was this stuff. So now you need to send this guy back to the system to say, here, optimize this. And Lightning will automatically do all the steps for you, right? So it will automatically set your model into training to make sure that in case you're using batch norm or dropout, it'll work. And then it'll automatically put the things on the correct devices here. It'll automatically do this backward, optimize your step, append items, track all the stuff. So, it removes all of this boilerplate stuff. So you don't have to deal with like, oh, did I remember to make my model into train or not, right? So that's pretty nice because it's automated. And like in
the previous video.
Exactly. So you don't need to worry that you like overwrite the wrong thing, or did you track the wrong accuracy, or is your model eval or not, right? There's just so many details. For validation loop, it'll disable gradients. But I'll talk about that when we get to the validation loop. So now we've defined the Lightning module here. So it's literally the same piece of code. I think there's some alignment stuff. So let me do that.
Yeah.
Okay. So we have all of this, optimizers, here, logits, great. And then you have your model, right? Great. So this is your RESTnet.
So you're returning, hold on, the training step, what is returning?
Oh, yeah, that's right. So here you need to return this loss, right? So you can literally just do that, and that will return the loss.
You told me before that you don't want to forget to detach stuff, right?
Yeah, so Lightning will detach it automatically. So you need to return it with a graph around it here. And Lightning will automatically detach that stuff. And you want to specify a key called loss, and then you pass in the loss, right? This is equivalent to doing this here.
And so you return a dictionary, and I believe that loss is a reserved word, is it?
Yeah, correct. Yeah, that's correct. So these two are equivalent. I'm going to use this syntax for now, though. So I'm not going to do this guy right now.
Okay.
So I'm just going to return the scalar itself.
You can leave it commented, right? It's okay.
Yeah. Okay, great. Sweet. Okay. So I'm going to return that. So now I init my model, and hopefully I have no bugs. Great. Now I need to train this, right? So here's where Lightning kind of helps a lot. So the way you think about Lightning is, this is what you care about in research. And if you're building anything with AI or machine learning, this is what you care about. Like, what is actually happening here? You don't necessarily care about how this stuff is trained, right? So you don't care if it's running on GPUs or TPUs or how all that stuff happens. That's all engineering stuff.
Well, sometimes I actually want to have control over, let's say, when I zero my gradient, right? So
yeah, that's a good point. You didn't want to overwrite something like the backward step. You could get on the documentation, figure out what hooks are available. PyTorch Lightning, right? So you can just Google search it, pick the first link.
Okay.
And then for the docs, you can click this up here, or there's a little button called docs here. The easiest thing is just to search what you want, right? So you can just say backward. So you want to override backward. So let's do that. And then you'll find all of these hooks, right? So I'm like, okay, cool. Let me override that backward. So now I see that I can override this method called backward. The beauty of Lightning is you don't have to deal with most of the engineering. You don't have to deal with really none of it. But in case you want it, it's there, right? So if you're doing more advanced research, you can always find it. Of course, so I'm going to remove this. So because we're not going to do anything custom in the back.
Let's do things in order.
Yeah. Okay, great. So we're here. Yeah. So now now this is where all the engineering effort, right, comes in, right? So now you're going to get this is all your code. So you can have bugs in here and that's okay. But in a deep learning project, you're usually going to have a ton of code, right? So the last thing you want to do is worry about did you overwrite the right losses? Did you call step before backward, or did you do append, or all this other stuff, right? Did you get the order right? So you don't want to mess around with that stuff. You want to make sure that stuff works well and it's tested.
Yeah,
what you do want to mess around.
Calling zero grad just after backwards is very nice.
Exactly. So what you want to do is just say, I don't want to worry about any of that. I just want to worry about my idea. And maybe you have a quick idea you want to try. You're working on a research project, or you're building something and you want to say, I want to try this out. And this will allow you to do this very fast. And then when you're ready to go, you can literally, it's just a PyTorch module, so you can run this. So the trainer is the key here, right? So the trainer is going to allow you to do all this stuff. So you can just init this trainer and then you call fit on it, right? So you pass the model in and then you call fit. And then what this will start doing, okay, wait, so I guess configure optimizers. Right. Okay. I forgot to pass in self. Look at that. Basic engineering. Okay. What we're actually going to do is, instead of returning just that single scalar, because I want to show how to log and show things in the progress bar as well, we're going to use the dictionary syntax, right? So we're going to pass this in instead. So these are equivalent. So I'm going to go ahead and use the dictionary syntax because I want to show how to log and how to track progress and different things like that. So I'm going to return this instead. So you put this keyword in here, loss, put that J, and then you go ahead and you init your model and then you fit it, right? And then it starts training and then you see this nice progress bar. So Colab is going to have issues. So I'm going to pause this for a second because that progress bar is updating too fast for Colab to keep up. So it's going to freeze my UI, right? So we're going to use the trainer flag here. That's going to slow down that bar. Well, the training is the same, but it's not going to update as frequently. So it's only going to update that progress bar, in this case, every 20 batches. And the reason for that is because I don't want to crash Colab. Okay, so I'll start this. And now you'll see that it's a little bit choppier, but at least it won't collapse Colab. So these metrics are estimates of that. So you see my loss here. This is coming straight from that training loop. So anything you pass on here, it's going to be showing you that. So this is going to continue. The trainer is defaulted to go up to 1,000 epochs. So obviously, if you need fewer epochs,
5, right? We did 5 before. How do you put epochs here?
Yeah, that's a good point. So we can just do max epochs, right? So max epochs, and we can just say 5 for 5 epochs. And this will train for a bit. And we are on a GPU instance, I believe. We are. Okay, great. Train this on GPUs now. So, when we had to adapt this for GPUs, we had to do all this CUDA stuff, right? So we had to I don't even know where the model is anymore. Yeah, so we had to do this. We had to call the model to CUDA. For each example, we had to do this CUDA. And then here we had to make sure that things were detached and on the right CPU and stuff to get this accuracy, right? So let's not do all of that in Lightning. We're just going to set this little argument called GPUs, and we're going to say 1. And then now that's going to train on GPUs. So you see it's available and we're using it.
Okay.
So you didn't have to change your code, and this is training. Yeah, so let's just see. Oh, the progress bar, what's going on? So let's see here. Yeah, there we go. Great. So it took a bit to start, but here we go. So it's a lot faster, and you're training on the GPU, right? Again, this model is not big enough and the data is not big enough to show a meaningful difference in speed. But if you had a huge data set, you would see a pretty significant difference. Even then, I think it's already faster, much faster. So yeah, I'm using that GPU. But the beauty of this is that you don't have to do anything to your code. You just trained, right? And that was beautiful.
So if you want to save this model, do you have to specify to CPU and things and?
No, so here I'm going to show you that every single thing we just did is available under this folder that Lightning created. You can modify that for whatever you want.
Oh,
and we have all these versions. So we ran this multiple times, and every single time we created a new version of that experiment, right? And so it tracked everything from the hyperparameters to the losses and everything we logged. We didn't actually log anything, so nothing showed up. But I'll show you how you could use this, right? So now we have weights on here, right? So if I do, let's see the latest version, and then we have this checkpoints folder in there.
You actually saved the model?
Yeah, so here, it's already saved. So I have this checkpoint here.
Okay.
Yeah.
Wow.
So now we have these checkpoints automatically saved for you. So this is saving the best checkpoint for you. So you don't have to deal with any of that. And yeah. So now we want to plot this because you were printing stuff to see the progress, and then you saved it in this copy paste thing here, right?
So it's saving the best checkpoint with respect to the
loss.
Which one? We only have
the one. Yeah, exactly. So in this case, it's only using the training loss. So it's literally it's not great because it's not cross-validating or doing validation. Yeah. So it's literally just going to save the minimal loss, which is in reality, you wouldn't do that, right? But let's log this first, right? So now let's just say that, okay, so you see this progress bar here? Yeah. It just says loss on it. So you wanted to calculate accuracy as well, right? So we have a metrics package called where all of this stuff lives, right? So PyTorch Lightning metrics .functional imports accuracy, I believe. This is a brand new thing. Okay, great. So now we have this accuracy thing. So now I'm going to show you that accuracy as well. So we go back to our training step, and I want to calculate that accuracy. And I'm going to just call accuracy. I'm going to pass in, where are my logits? I guess logits here.
Yep.
And then my Y, done. So that's my accuracy. So that's better than all of this stuff here. That's
my one-liner. I'm proud of it.
It's a great one-liner. Yeah, for sure. What's cool about the metrics package is Lightning lets you not just train on one GPU, but if I change this number and I had a huge GPU machine, I could train on 8 automatically.
Oh wow!
And the metrics will actually be calculated across all GPUs as well, so you don't have to deal with any of that.
Okay,
so it's just automatically done for you.
I never used more than one GPU. I don't know how to. I don't know how
to. Well, now you will, right? So okay, so we calculate our accuracy. And we want to show that in the progress bar. So I'm going to show you how to do that first, right? So I'm going to call this a P bar. And then that's going to be just a dictionary. And what do you want to call that? Train accuracy? Sure.
What is P bar?
Progress bar.
I see. Okay.
Yeah. So let's just call that the training accuracy, right? So that is going to be called progress bar, right? I believe there's a underscore.
It is also a reserved word.
Yeah, exactly.
Okay.
So in this, in this return statement, you have 3 main reserved words. One is the log, right, which will show next. Then it's the loss specifically, and then you want to show stuff to the progress bar. You have this progress bar key, right? So you're going to use that. So I put that over this guy. So I'm going to delete that now. So I'm going to show that accuracy in the progress bar, and if we did everything right, that should just work. Great. So now we have this accuracy up, and it's printing to my progress bar. So I don't have to do anything. And now I can see the accuracy of what's happening. So Lightning implements in the metrics package, which is built by some of our core engineers, core developers, implements most of the key metrics like F1, ROC, that kind of stuff. And I think the beauty of Lightning is that it's a community project. So it's contributions from people all over the world. Most people are PhD students or researchers, research scientists. We have people from Facebook. We have people from NVIDIA. We have people from all of these different companies who are contributing different things. And so it's really helpful to have all of their kind of inputs and work kind of feed into Lightning. So you can think about this like a joint research project where like everyone in the world, instead of coding accuracy for yourself, you code it for like the whole world and they can all use it, right? And then we, the core team, validates that stuff is correct and implemented well.
Big so responsibility, that we can, right?
I'm sorry? Yeah, exactly.
If you fuck up, then you fuck up very big.
But we have tests. So we have very thorough tests to make sure things are not wrong. And for accuracy, these kind of metrics, we will usually ask that people benchmark against another, something like NumPy or sklearn, to make sure that it's correct, so that we know that we're not off. Okay, so this model is training, and I guess we're getting about 90%, 96% accuracy in 5 epochs, which is pretty cool. Oh, 1. Okay, well, that's definitely overfit. Into the validation loop. So we use validation to save the best weights, right? To stop training, to track, to see if our model's overfitting or not. So in the validation loop that you wrote, notice on here, we had to do this eval stuff, right? And then we had to print a bunch of stuff, and then you had to disable gradient. So all of this is automated for Lightning. So it's literally the same code. The only difference here is that really the validation loop, again, you're not learning anything. So what is the point of a validation loop? Is to save things or to plot things, right? Or to do something where you want to evaluate on the data. So as a result, Lightning has 2 methods that you can use for that. So you have this training step, right? Which did all the stuff that you cared about.
Yeah.
So we're just going to add the validation loop, which is going to be validation step, right? So it's the same concept of the training step, except the batch is going to come from the validation data set, right? So same thing. So we could literally just call, we can call the training step instead, right?
Oh, no way. Okay, so cool.
So we can just say self-Dutch training step, and then just pass in the batch and the batch index, right? We're just going to use the same code. We're not going to change anything about it. That's going to give us this little dictionary back, right, of stuff.
Yeah.
So great. I'm not actually going to do anything. I'm just going to return that dictionary results.
Okay.
Yeah, cool. Okay. Yes, perfect. Okay, so I'm going to return that. So that's going to, so what is the difference here is that we want to, in validation loop, we generally don't want to put metrics for every batch because it doesn't make sense. All the batches are independent, right? What makes sense is to plot or show metrics for the whole validation set. So when you want to know your accuracy, you don't want to know your accuracy for one batch. You want to know it for the full validation set. So what this is saying is for every single batch, right, in the validation loop. So this part here, right here, this guy, all of this, really just this stuff here. I want to know the loss or whatever you cared about, right? In this case, I cared about the accuracy and the loss.
Yeah.
So just return it, right? And Lightning's going to cache these, and it's going to do that for all the batches. And then when the training loop is done, the validation loop is done, you're going to get all those outputs back, right?
Yeah.
So this is called validation epoch end, right? So this is your chance to take all those, I'll call this val step outputs, right? So what you're getting on here is a list.
I guess this is also a hook, as you said before.
Yeah, exactly. So these are hooks. Okay. So you're gonna end up getting this guy here, right? You're gonna get many of these guys here. So batch one, batch two, batch three, and so forth, right? So you're gonna iterate through those. So let's just say I wanted to show you my validation loss, right? So now I'm going to just calculate my validation loss, right? This is gonna be an average validation loss though, because it's for the whole validation epoch.
Like I've done for the other code, right?
Yeah, exactly. So we're going to loop through this guy here. So X for X in outputs. Okay. So this X is this results thing here, right? So this guy here, that's X right now, this. So we want to pull out let's just say, what do we want? The loss? Sure, let's pull out the loss. So we pull out the loss, right?
I see. Okay.
And then that's going to give you an array of losses. So this, I want to take a mean or something like that. So first I need to put that back into a tensor, right? So I'm going to say tensor. And then I'm going to mean that tensor. Yep. Boom. So now I have my average val loss. So now this is, so here we return, the outputs from this step went here to this loop, right? So validation step went to the validation epoch end. And in the loss, this went into the system, right? So that's like the end of the loop. The end of the batch. At the end of the loop, we want to also put stuff back into the system so we can plot it and show it and whatever you want. So we're going to use another dictionary here, right? So I'm going to return something. So what you return on here doesn't matter. I could return like, I don't know, 4. It doesn't matter, like, because all of this will be plotted. So if you don't use the correct keywords, they won't be plotted or anything, right? So there are a few reserved words. So if you want to do, so you asked me how we were saving checkpoints, right? So here we were picking just the minimum on the loss, on the training loss here. Yeah. So in this case, we have this early stopping and model checkpoint callback, which I'll explain in a bit, but they're all looking for this keyword val loss, right? So they're all looking for that word.
And
right?
if it's missing, it goes for the other one, for the loss.
No, if it's missing, it won't do anything, right? It won't actually check. It'll save checkpoints based on the loss, as you're saying. Yeah, but it won't early stop. So you won't get early stopping behavior. Right?
So there is early stopping automatically integrated?
Yes, exactly. So let's show that in a minute, but let's just say that I want to track my validation loss as my metric, right?
Sure.
So I'm going to pass in this average val loss.
They also the accuracy, right?
Yeah. So if you want to do the accuracy, so why don't we do that as well?
Thank you.
So remember that was we need to access the progress bar, right? So that's a dictionary itself. That's this guy here.
Oh, I see.
And then and then we need to access the training accuracy. So we're going to do that, right? Train acc. Okay, great. So average val acc. Sure. So in this case, actually,
I feel uncomfortable. We access the train acc to compute the val acc.
Oh, well, we named it that, right? If we didn't want that, we could have done this, right? So I could have, in the validation loop, I could have said results, progress, bar, and then, come up with a new keyword called val acc, which is going to be the same thing here. So we're going to pull the thing from, because we use the same loop, right? We pulled it from the training stuff. And then we're going to just use the train acc here, right?
And then we also kill the training acc.
And so then we'll just we'll delete these guys here. Yeah.
Thank you.
Cool. Okay, so now we get rid of that.
Del, right? No def.
Oh, yeah, sorry, good point. Okay, del. So we'll delete that. So now we have this train acc, which is here. Val acc.
Val, yeah. Okay, now I feel less.
Great. Less anxious. Okay, so again, the only keyword here that anyone cares about for early stopping or checkpoint is this one. You can change that word if you want, and I'll show you later how to do that. But right now, I wanna show this on the progress bar, right?
Okay.
So let's do another p bar guy, and then we'll call this val, let's just call this average val ac. And then I'm going to pass in this average val ac, right? Cool. So I get this p bar here. And now I'm going to just come up with my, again, it's the same words, right? So progress bar, I want to send that to the progress bar. So I'm going to send that information to the progress bar. So that's it. So now I have a validation loop. So many details in deep learning that we don't want you to get stuck in those details. We want you to focus on the research and the science. So let's come up with this val data loader here, right? So in this particular case, again, this model is still wedded to MNIST, but we're going to keep it that way for a minute. So what we're going to do here is in this train data loader, I'm going to just copy paste the same code because why not, right? It's the same stuff. So we're doing the same splitting work. But in this case, I'm going to not use this. I'm going to use this instead, right? So now we're going to use this training split. So I need to enable this. So now I'm going to use the training split. So MNIST in particular has two official splits on Torch Vision. It has the training, and then it has the test split, right? Yeah. So we want to save the test to see how our model actually generalizes. So to do validation, we're going to take our training split and we're going to split it into train and validation, right?
Yeah, but right now we are making two different random splits, right?
Yeah, exactly. Actually, an easier thing is let's just call this self.train and then self.val. Then that'll be a lot easier, right?
Yeah.
Cool. So let's just do that. So now I'm going to copy this guy here, and then I'm going to return that val data loader, and that'll be self.val.
And self.train.
Yeah, exactly. Cool. So one thing to consider is
you have to return the other one.
So because Lightning starts to let you use multiple GPUs, you have to start caring a little bit about how you download data and everything else. So I'll give you an example. Let's say that you set this to I don't know, 8 GPUs, and then you want to do this on 32 nodes for some reason, right? Like this is a giant network. Now I'm going to train this on 32 times 8 GPUs.
Hold on. What are the nodes?
So each node is a machine on a cluster, and each node has so many GPUs on it, right?
But
so,
how do you talk between machines?
Yeah, that's the beauty of Lightning. You just have to spin up the job, and it'll talk between machines, right? So if you submit this to a cluster, for example, like Slurm, if you submit this job, then as long as you specify in your Slurm script that you need 32 nodes and each node has to have 8 GPUs, then Lightning will just know how to do that automatically. What's going to happen is this. If all those nodes share the same file system under the hood, then you want to download the data once, right? Because why would you download data from, I don't know, what is this, 256 GPUs? Why would you do that? You'd have 256 downloads, right? So you don't want to do that. So instead, what you want to do is download it only once, right? Sure. So in that case, if I were doing something simpler like 1 or 2 GPUs, I would leave this as is and move on, right? Otherwise, if you know you're going to be doing this distributed stuff, then you want to use this method called setup, right? So let me do it here. We're going to use prepare data, and then I'll show you setup. So we're going to use prepare data. So this is like, hey, do whatever you want to happen only once, right? Like we make sure that when we call this method here, it's not going to happen on every GPU. It's only going to happen on a single GPU.
Difference between prepare data and then init. Isn't init going to be running at the beginning once?
Well, no, init happens here before you put it into the trainer, right? So the data loader stuff will be called at the right times. So you define the data loader functions here, but the data loaders are not instantiated until you actually need them, right? So Lightning has lazy loading there. So it's not until you, like, for example, it's not until you get to the validation loop that your validation data loader will actually be called, right? And it's not until you get to the training loop until the data loader actually gets called.
Okay.
Yeah. So basically this stuff happens later, right? So if you want to download your data, like what I would suggest is to put this into your prepared data. So you put that there, right? And you don't actually need any of this. So you're just going to do that. You're just going to download the data here. Now, we were doing this like self.val, self.train splitting stuff, right? So that's easier that's actually easier in this method called setup, right? So again, this is only needed if you want to really do multi-GPU stuff. If you don't care about any of that, then you don't worry about any of this. You literally just define your train and data loader, and that's it, right? But in the world where you are doing multi-GPUs, then what you actually want to do is you want to, in this particular case, this MNIST implementation from Torch Vision, it won't download twice, right? So if you have it downloaded once, it won't download. So here, what it'll do is it'll just pull the data set, right? So it'll pull this guy here. And then we can do the splitting stuff here, right? So we can do that in the setup. So this is where we do the train and val kind of splitting, right? So in this particular case, I'm just going to save those on there. So my setup is pretty trivial here. Now, to your question, if you had transforms, right, you could do things like random flip an image, normalize an image, whatever you want on here, right? Yeah. So you could just put those on here and do that stuff. Cool. Okay, so we're going to do that splitting and setup. And then again, setup is going to run on every single GPU. So it's okay to assign state, something like this. It's like self.something. That's okay in setup, but it's not okay in prepare data because it's only going to work on one GPU. When we're doing multi-GPU training, what you're actually doing is you're setting up a model per GPU, a copy of that model, right?
Okay.
Yeah, exactly. So that's what will happen. So we have this self.train, self.val thing here. So now we can just pull those out. So I don't need this anymore, right? So I'm going to delete this, and then I'm just going to pull my data loader from there. And then same for here. So, okay, so this is, I mean, pretty much the same setup. It's just like we split it in a different way, but this will allow you to scale up to, I don't know, multiple GPUs, multiple TPU cores as well, and like a very, very safe way. There are obviously some nuances. So on this prepared data, it's called from a single GPU, right? So that makes sense if you have multiple nodes and they're all using the same underlying file system. If that's true, this will work. But if all your nodes have their own system, like if you have 5 different machines and they'll have their individual disks, so Lightning will detect that automatically and on each machine download the data individually so that you have that there, right? So you don't have to deal with this as well. So that will happen there.
Okay, so we went just over converting our PyTorch code into PyTorch Lightning, and we saw so many benefits. In the next episodes, we'll dive into more advanced topics, so stay tuned.